Good morning, Radnor Elementary School fifth graders. Mr. Serpico checking in one last time. This is going to be the last math video from fifth grade. So just want to congratulate you guys on a great school year. You've been really wonderful children, hard workers, and I know this hasn't been ideal for any of you, this type of instruction, but I do appreciate you tuning in and doing your best as I tried to guide you through these lessons on behalf of your teachers. So, Chapter 14, volume surface area, rather than doing some type of assessment, what the schools decide to do is just hop into one lesson on Chapter 10. Obviously, if we were here that next week, we would have gotten through Chapter 10. But this particular skill is not something that's required in fifth grade curriculum. So, touching on it today will be a nice intro to fractions, decimals, and percents. And you're going to find out quickly that you already understand a lot of these core concepts. And they'll appear next year as you guys enter into course one at Radnor Middle School or whatever school you decide to attend next year. So without further ado, let's hop into some of these concepts from Chapter 10. And let's look at this first scenario, this first scene you got going on here. So it looks like this young lady is doing some shopping. It looks like it might be a book fair. A familiar scene for all of us. The Radnor PTO has put on many a book fair for us. So take a minute to study the screen and make some thoughts, some predictions inside your head. Look at her question. Okay, so maybe as a Radnor Elementary School student, you get discounts. You get the privilege of a discounted purchase price. So what does that mean? In the world we live in, fractions, decimals, and percents, they all kind of work together. And some of you are saying, well, why do we need percents if they're all the same thing? Why can't I just use decimals? Why can't I just use fractions? Well, sometimes when you're comparing numbers that are very different, comparing situations that are very different, sometimes it's best to have a percent to help you analyze those. And I'll go into more examples after this one as we go through this lesson. But 45% off of $25.50, 50% off of $38, and 65% off of $25.50 for the different items. What's the best deal? So she wants to get the checkers, the checkers game. So what is 65% off of $25.20 and how much would she pay? These are the types of math equations we'll look at here today with this chapter. One of the ways I mentioned decimals as a connection to percents, one of the ways it's easy to visualize, percentages are based out of 100. So the easiest example is if you take a math test and you get every question right, that's 100%. So one application of percentages in a real life is school. Percentage of accuracy on an assessment. And that's how grades are determined. So 90% accuracy, you might say that's close to an advanced understanding. If you're at 80% accuracy, you're at a proficient level of understanding, maybe even 70. But if you're down around that 50%, you've got a basic understanding. You know about half the material. So this is a great visual that shows you 37 hundredths of the shares is shaded. 37 hundredths can be written as a decimal, 0.37. 0.37 is the same as 37 over 100 or 37 out of 100. So this is a good visual. And what percent would this be? 37% of the grid is colored. All right. Back to the checkers. It looks like she bought that checkerboard. What fraction of the checkerboard is shaded green? What fraction? What is this fraction expressed as a percent? So if you think about it, if you're playing a game and the board is green and white squares, shaded and unshaded, in a game of checkers, you'd say about half, right? Half the board is green, half the board is white. So what percent is that? 1/2, 1 out of 2. Well, that's 50%, right? 5 out of 10, 50 out of 100. Half. Whenever the denominator is double the numerator, it's 50%. So 10 out of 20, right? 25 out of 50, 50 out of 100. So half this board, 50% of this board is white, 50% of this board is green. So how do you do that? What's the math? You might remember from previous chapters that finding equivalent fractions by multiplying the numerator and the denominator by the same number. It's really convenient when the denominator is 100 and the other fraction, the denominator, is a factor of 100. Or in other words, you could skip count by this number and get to that 100. Makes it really easy, right? So 1/5 is how many hundredths? Well, 5 goes into 100 20 times. So 5 times 20 is 100, and 1 times 20 is 20. So you've got to multiply your numerator and your denominator by the same number to convert that to a fraction. It works the same way when you're going from a larger fraction to a smaller one, when you're using that idea of simplifying, reducing, in lowest terms. We teach those 3 terms. They're synonyms. They mean the same thing, and you'll hear them in a variety of ways as you move forward as mathematicians. Simplifying, reducing, lowest terms. Simplifying fractions. Let me grab a pen here. Simplifying fractions by dividing the numerator and the denominator by the same number. So if your original fraction is 15 over 100 and you want to simplify that, okay, you want to put that in the lowest terms, you say what number goes into 15 and 100? What's that greatest, you hear this greatest common factor, the GCF. The greatest number that goes into both 100 and 15 is 5. So you divide 15 by 5 and you get 3, and you divide 100 by 5 and you get 20. So 3/20ths, that's the simplified fraction. And sometimes you want that simplified fraction, and sometimes you want that percent of a number, which is always over 100. Always over 100. All right, so we're looking at the decimal connection. Here, back, we're looking at fractions. Now we're looking at decimals. Finding equivalent fractions and decimals. So here's a decimal number line starting at 0 and ending at 1 whole. And then everything that comes in between. The first number they're looking at is 15 hundredths. 15 hundredths. Remember, this number is 1/10. And halfway between 1/10 and 2/10 is 15 hundredths. So here's your number 15 hundredths. Okay. 2/10, 3/10, 4/10. 5/10 is also 50 hundredths, right? 50 hundredths. And you could see the connection between the fraction and the decimal. You actually say it the same way. So in other words, if I said to you, tell me how you would write 3/10, and you all had whiteboards, and we're sitting in the classroom in Radnor Elementary School, hypothetically. I say, okay, kids, take out your whiteboards. Write 3/10 on your board. Maybe half of you would write this, and half of you would write this. You know what? Maybe some of you would just write both, right, as your answer. And you'd all be correct, because I didn't really specify 3/10 as a fraction or a decimal. So you can write numbers in a variety of ways. Down here, you've got your 72 hundredths as a decimal, and here's your 72 hundredths as a fraction, right? So when would you want to use a fraction? When would you want to use a decimal? It really depends on the situation. A lot of times, if you're talking about money and discounts and percents and interest, you're going to want to use the decimal form. So let's move on. I don't know if there's a lot of basketball fans out there and you've been watching any of that Last Dance. I know that some of the language isn't great for kids, but a lot of times when you think about percentages, you think about sports. So suppose I have, forgive my drawing here, I have baseball player number 1, softball, baseball player number 2. Let's give him a little hat. All right, just having some fun here. And I'm the coach. And I have to think about, we'll just call him ball player 1 and ball player 2. And I have to decide which ball player do I put into the game to hit. Let's say we're down by a run and the bases are loaded and I've used up a lot of my players, and I have to decide to go into the game, which of these two batters should I use? So I can think about math. I can think about percentages now. Okay. I could look at, or I could know how many times ball player 1 gets hits versus ball player 2 gets hits in this situation. So I'm thinking, like, say it's a right-handed. They're both right-handed batters. There's a left-handed pitcher, so it doesn't matter from that standpoint. You're just going to get either one. It's still even, but one player has gotten a hit, let's say 22 out of 118 at-bats that season, and the other player has gotten a hit in 19 out of 80 at-bats. It's not easy to compare numbers if they don't have that same denominator. It's not easy to compare numbers if they don't have those common factors to quickly reduce them into a simplified fraction. So in that case, you want to figure out the percent and see which batter has the better batting average. So perhaps in this case, it's better to go with the player with less at-bats but more hits and less at-bats. And that's how you can make a decision using percentages. And the reason I bring that up is because when I look at this page, I've got my little symbols here I used as basketball hoops. I'll go back to the Last Dance analogy, which was a great basketball team from the 90s with a player named Michael Jordan. And when you take a shot in basketball, if the basketball goes in, it's called a field goal. So when you play basketball, you want to have a good field goal percentage. So let's pretend that in this scenario, we're figuring out some field goal percentages. So in number one, the shooter made 18 out of 100 shots. So they want you to do this as a decimal. So what does 1800s look like as a decimal? Hopefully you've got your notebook and your pencil with you and you can jot these down. Number two is 65 out of 100 as a decimal. Number three, 24 out of 100. And number four, 53 out of 100. Go ahead and pause it right here and solve these. The first two are as decimals, and the last two, you want to write them as a fraction. Okay, so 1800s, 6500s, 2400s, and 5300s. Okay, so the thing about number three is it's not simplified. So what would that be? Go ahead and try to simplify that. Ask yourself, what factor goes into 24 and 100? What's your greatest factor? Let's say you started with 4. So you're going to divide by 4, and you're going to get 6/25. Was that the greatest factor? Can you go any lower than that? Let's see. You never simplify by 1. 1 divided by 6 is 6. Or 6 divided by 1 is 6. And 25 divided by 1 is 25. So that wouldn't help you. 2 goes into 6, but not 25. 3 goes into 6, but not 25. 4 doesn't go into 6 or 25. 5 goes into 25, but not into 6. And then 6 goes into 6, but not 25. So the good news is 4 was your greatest common factor. The final answer here is 6/25. Let's move ahead and let's try a few more examples. So let me just overview the page and then I'll let you guys try some practice. 5/100 is blank out of blank. So let's see what they're asking you to do here. Is 5 out of 100. So you are just trying to figure out, obviously numerator and denominator. And this would be like you made 5 out of 100 shots. 21 out of 100. This next one here is 95 is blank out of blank. Whoops. 73 is 7300 is blank out of blank. So I'm going to stop talking. In the bottom area, you're going to find the missing number, numerators and denominators. So I'm going to stop talking. I'm going to let you guys try to fill in the blanks for numbers 5 through 12, and then we'll come back together and go over those answers. So pause it right here. Take a minute to solve. Okay, and now let's see. 21 out of 100, 95 out of 100, 73 out of 100. 3/5 is 6/10, which is 60/100. 9/10 is 45/50, which is 90/100. 3/4 is 6/8, which is 75/100. 4/5 is 16/20, which is 80/100. So the reason they're doing the hundredths is because we're working towards that percentage, right? And percentages are always out of what? 100. That's an important number. Okay, last slide. Express each fraction in simplest form. I demonstrated earlier in the lesson how to do that. Just a quick reminder. I know you guys know how to do that. We've done a lot of fraction work, particularly chapters 3 and 4 and 5. I think were a lot of chapters. 3 and 4, I know for sure. So express each fraction in simplest form. Ask yourself, what number goes into my numerator and denominator? What's the greatest common factor? If you can't think of your greatest common factor, think of a factor, and then we used to call it in Team 19 the chip chip away method. Okay, if you can find a factor and then just keep going until you get it all the way simplified. I know I've had a few moments of where my brain hasn't worked over this break. So you might have forgotten some things and then you just figure out a way to solve it. So we used to use that chip away method with reducing. 35 over 100, what number goes into both 35 and 100? Down here, you're going to find the missing fractions and decimals. We did one earlier. You've got a number line, and you're trying to match up. So I'm going to ask you to pause it right here, and we'll come back together and go over these answers. Okay, so here we go. 15 over 25 is 3/5. So you divided both of those by 5, right? 35 out of 100 is 7/20. Again, you divided each of these by 5. 100 divided by 5 is 20. 35 divided by 5 is 7. All right, 6 100ths is 0.06. 35 hundredths is 35 over 100. 52 hundredths is 52 over 100. 75 hundredths is 0.75. All right, and of course, this is a really good one to know as a fraction, 3/4. All right, so we took a quick overview at fractions, decimals, and percents. And tomorrow, Wednesday, would be a day where you can do some Khan Academy or Prodigy. And that's a tool that you guys could use all summer long. So you'll hear more from your teachers in the next few days, but just wanted to wish you a safe, happy, and relaxing summer. I know it's been a crazy couple months in America, in the world, and I want you to have a great time with your family and your friends as we slowly will get back to normal. Thanks for your time and attention, and I'll see you guys around.